All right, this is lesson 5.5, function word problems. Our objective is that you'll be able to identify different parts of a function and its meaning. So I have a table for you right here. You can refer back to this as you work on these word problems in Khan. It gives you some keywords. So if you see something like dependent variable, we're talking about f of x, our outputs. X would be our inputs, or our independent value, the value that determines the outcome. It's also the number you put inside the parentheses in function notation. And you can go down the list and use these at your convenience. I do want you to make a note here for M, for slope, specifically when you see rate of change. In a lot of these word problems, when we're talking about a rate of change, you might be asked about the speed of an increase or decrease. That's an increase or decrease, that's a change. And the rate at which you're increasing or decreasing would be like a speed at which that's changing. So oftentimes it'll be worded as like what temperature increased faster, or when did the price increase or decrease faster, something like that. That's definitely referring to a rate of change. This is a speed of an increase or decrease. In fact, we see that in the first example. We'll have some average rate of change word problems, just like this one. I know it was printed a little bit small, so just bear with me right where you can. It says, T of T models the temperature in degrees Celsius in Windhoek, Namibia, when it is T hours after midnight on a given day. So, first of all, we have capital T that models the temperature in degrees Celsius. We also have lowercase t that is time. It's hours after midnight. So when lowercase t is 1, that's like 1 a.m. Or when lowercase t is like 6, for example, that would be talking about 6 a.m., 6 in the morning. 9 hours after midnight is 9 a.m. And 13 hours after midnight, that's the same as 1 p.m., right? So when it asks about 1 p.m. later, we have a data point for 1 p.m., okay? All right. So it's asking, when did the temperature increase faster? Maybe it was between 6 a.m. and 9 a.m. This is an average rate of change because we're talking about a temperature increase and the speed at which that temperature is increasing. And remember from last chapter, average rate of change stuff, we're going to find the slope of the line between these 2 points. Make that a little thinner. Between these 2 points. So we can use our slope formula. Using those points, we would have, in fact, let me move this up a little bit. If we subtract our outputs, our y's, I know really we're using capital T for temperature, we'd have 25 minus 19 over lowercase t would be our inputs, 9 minus 6. We would end up with 6 over 3, which is 2. So the average rate of change between 6 a.m. and 9 a.m. would be 2, and we should really include our units. I'm going to put the equals 2 down here so that I can write degrees. That was the numerator, the temperature. These are measured in degrees Celsius, and the denominator was hours. So we can say the average rate of change was 2 degrees per hour between 6 a.m. and 9 a.m. Now let's find the average rate of change between 9 a.m. and 1 p.m. That would be these points here. So again, using the slope formula to find the slope of the line between those 2 points, we would have 31 minus 25 all over 13 minus 9. When we subtract, we would get 6 over 4. Wait, that's just 1.5 though, right? So that's 1.5 degrees per hour. So of the two, we know that 2 is bigger than 1.5. So the temperature increased faster between 6 a.m. and 9 a.m. All right, let's try another one. So we have P of N, and it models the price in dollars of a pack of N bulbs at a certain store. Again, it asks, when does the price of a pack increase, that's a change, faster? So we're talking about a rate of change again, an average rate of change. So we need to test what's the average rate of change, or the slope of the line through when N is 4 and when N is 10. Remember, N is the number of bulbs, and P is the price, right? So we do the same thing. We're going to find, here, let's see. I'm going to write it up here towards the top this time. Between 4 and 10 light bulbs, the average rate of change would be, I guess I'll highlight it here in yellow. It'd be 25 minus 12. We subtract our outputs first. And in the denominator, we subtract our inputs, 10 minus 4. So 25 minus 12 would be 13. And then 10 minus 4 would be 6. Now this isn't a nice whole number, but 13 divided by 6, it's a little more than 2, right? We could say it's 2 and 1/6. I'm just going to leave it as 13/6 for now. Our other interval that we need to test is between 10 and 12 light bulbs. So that's these points here. And we can use those points to find another average rate of change. We would have $28 minus $25 in the numerator over 12 bulbs minus 10 bulbs. So we would end up with $3 for every 2 bulbs. And, oh, I forgot to write the units here, but this is dollars per bulb. And then that one in black is also dollars per bulb. BULB. Oops. There we go. Okay, so when does the price increase faster? We need to find out, is $13.6 of a dollar per bulb more or less than 3/2 of a dollar per bulb? Well, 3/2 of a dollar, 3 over 2, that's $1.5 per bulb, right? And this one, that's over 2. That's 2 and 1/6 dollars per bulb. So that one's more. This has a faster increase in price between 4 and 10 light bulbs. All right. Try the last one on your own. You can use the first 2 that we just did as an example. But we have P of T. It models the number of people at the beach in Rio de Janeiro, Brazil, when it is T hours after midnight on a certain day. All right. Do this one on your own and then come back and check your work. Okay. So using those points, we should have found these average rates of change. So between 9 and 10 a.m., the average rate of change was 39 people per hour. And then between 10 a.m. and 3 p.m., that's, remember, 15 hours after midnight is 3 p.m., we should find the average rate of change is only 29 people per hour. So the first choice between 9 and 10, that had the higher rate of change. All right. We also have word problems about function notation. So with function notation, let's let's just dive right into it. Copacabana Beach in Rio de Janeiro is one of the most popular beaches in the world. P of T models the number of people at the beach T hours past midnight on a specific day. So right off the bat, they're telling us that P of T, the letter P, this is our output, and it's the number of people, where T is hours. T is an amount of hours. It's a time. So that means this number 10 here, we're talking about 10 hours after midnight, which would be 10 a.m., right? And they tell us that capital N, we don't know what the number is, but that number N, that would have to be the number of people, right? So since we can kind of interpret that, knowing what function notation represents, let's look at our choices and see which answer makes sense. Does it make sense that there were N people at the beach at 10 a.m.? Well, N is the number of people, and it says N people, so that's a good sign. And then 10 hours after midnight, 10 a.m., it does say 10 a.m., so that's looking good. Let's go ahead and circle that one. That makes sense. But just to be sure, let's check the other ones. There were 10 people at the beach. Well, wait a minute. 10 wasn't a number of people. 10 was a number of hours. So no, there was not 10 people. It doesn't say anything about the number of people. So it can't be choice B. And then choice C, there was an equal number of people at the beach at 10 a.m. and N hours past midnight. Well, wait a minute. We don't know how many people. We just know it's N. We have a variable there, so it can't be that either. Also, it says N hours past midnight. N's not a number of hours. It's a number of people, so that's not a choice either. It's got to be A. All right, let's interpret the second one, and I'll leave the third one for you to do on your own. All right, so Tessa's class had a math exam where the grades were between 0 and 10. We're going to use N as a function with the input G, and it models the number of students. G is the grade on the exam, so G could be between 0 and 10. So what they're saying here, N of 8, I should probably mark it this way. This is the number of people who got an 8 on their test, on their exam. And this, use a different color, N of 5 is the number of people who got a 5. All right, so let's check our options. The number of people whose grade was higher than 5 is greater than the number of students whose grade was 5 or lower. Well, wait a minute. This is the number of people who got exactly an 8, or the number of people who got exactly a 5. So I don't think this is it. The next one, there are 8 students whose grade was higher than twice the grade of another group of 5 students. Well, wait a minute. 8 was a score. 8 was a value for G. 8 was not a number of students. So that's not it. Let's check our last one. Hopefully that works. The number of students whose grade was 8 is twice more than the number of students whose grade was 5. Well, yeah, that's it. The number of students who got an 8 is greater than twice the number of students who got a 5. So that's it. Awesome. Try the last one on your own, and then come back and check your work. All right, so you should have chosen option B, and we'll talk about why. This is Amelia's height at 30 months. It should be equal to her height at 25 months plus 5. So if we're talking about a height in centimeters and we're adding 5 to it, this 5 should also be centimeters, right? So if we try option A, that doesn't work because 25 is a number of months, her height at 25 months, not an amount of centimeters. B is exactly right. That's what's described in this equation. It can't be C because it's saying 5 months. And we just said 5, since we're adding it to a height, 5 also needs to be a height. 5 is a number of centimeters, not a number of months. As always, ask a question at the end of the video, and I'll see you all in the next one.